Hey everyone. So, you've probably been hearing this phrase everywhere lately, the AI supercycle. Well, today we're going to tear that idea apart and see what's really inside. And trust me, it's a wild story that starts with stock markets going completely haywire, but it ends somewhere, well, somewhere microscopic, with some truly mind-bending tech that's changing the future of everything. Ready? Let's get into it.
Our story really kicks off right here with this headline. Suddenly, the South Korean stock market, which is a huge bellwether for the global tech scene, it just went vertical. It felt like the AI supercycle wasn't just some buzzword anymore. No, this was real. It was like a tidal wave of money finally crashing onto the shore.
And I mean, just look at this chart. It tells you everything you need to know. After kind of bumping along, the market just, boom, it rockets to these insane new highs. And this wasn't just a little blip. This was a massive system-wide surge. Which leads us to the big question we're tackling today. What is actually going on here? What's the real technology that's driving this modern-day gold rush?
To figure that out, we're going to peel this thing back like an onion. We'll start with that big market explosion. Then we'll find the single catalyst that lit the fuse. From there, we dive into the physics, a huge wall we've hit. And then, finally, the incredible breakthrough that changes the entire game.
Okay, first up, the explosion itself. This wasn't just numbers on a screen, you know? This was a tidal wave of investment flooding into every corner of the industry.
So what's fascinating about this is who was winning. It wasn't just the obvious names. Sure, you had the giants like Samsung pop over 7%. SK Hynix announced a jaw-dropping 21.6 trillion won investment. But look down the list, Hanmi Semiconductor, a company that makes the equipment to make chips, shot up nearly 30% in a single day. Even LS Electric, a power grid company, got a huge boost. And why? Well, think about it. All those new AI data centers need a colossal amount of electricity. The entire ecosystem, from top to bottom, just lit up.
So you have this whole ecosystem catching fire. But every fire needs a spark, right? What was the one thing that actually lit the match?
And that spark, without a doubt, was NVIDIA. When they released their earnings, they didn't just beat the estimates, they absolutely obliterated them. It was the ultimate proof. All the hype, all the speculation, NVIDIA's numbers were the hard evidence that the global demand for AI chips wasn't just real, it was astronomical. That single report sent a shockwave through the markets, and investors started throwing money at any company that was even remotely connected to AI hardware.
But here's where our story takes a sharp turn. You've got this bottomless demand for more powerful chips. The problem is, the way we've been making chips better for the last 50 years, it's broken. We've literally, physically, hit a wall.
For decades, the magic recipe was Moore's Law. It was simple. To make a computer faster, you just shrink the tiny switches, the transistors, and cram more of them onto a piece of silicon. Smaller meant faster, it meant more efficient, and it was the engine that powered the entire digital revolution.
But as we have shrunk these things down to the atomic scale, we've run headfirst into the weird, wacky world of quantum mechanics. At this size, the little walls that are supposed to keep electrons in place, they don't really work anymore. The electrons just tunnel right through them, almost like tiny ghosts walking through a solid wall. This causes all sorts of problems: errors, signal leaks, and a huge waste of energy. The bottom line is, we can't really shrink things down anymore. The party's over.
And this creates a massive dilemma, right? AI's hunger for more power is growing exponentially, but our main method for feeding it for half a century has hit a dead end. So what on earth do you do now? How do you keep this whole revolution from grinding to a halt?
The answer, and honestly, this is the key to this whole story, is a truly brilliant shift in perspective. If you can't build wider anymore, there's only one way to go. You have to start building taller. You have to go 3D.
And this right here shows the new approach perfectly. It's called chiplet technology. The old way, the monolithic way, was to build one gigantic complex chip, and every single part of that chip had to use the absolute latest, most expensive manufacturing process available. With chiplets, you just break it all down. You make a bunch of smaller, specialized chips. Think of them like high-tech Lego blocks. Your CPU is one block, your memory is another, and you can make each block using the process that's best for it. It's cheaper, it's way more flexible, and get this, it cuts development time from 4 years down to just 1. It's a total game changer.
So the process is pretty elegant. First, you design your specialized Lego blocks. Then, you make each one in the most efficient way you can. And then comes the final crucial step. You stack them on top of each other and package them all together. You're literally building a silicon skyscraper.
But, of course, there's a catch. Stacking these chiplets vertically creates a brand new, massive challenge. How do you connect all these different layers? All that data has to flow between them at unbelievable speeds. If it doesn't, you've just invented the world's most expensive traffic jam.
The old-school method uses these tiny little metal balls or bumps to make the connections. Think of them as the lanes on a highway connecting the different floors of your skyscraper. But there's a physical limit. You can only pack these bumps so close together, about 10 micrometers apart. For the kind of data AI needs, that is nowhere near enough bandwidth. It's a bottleneck.
And this is where the real hero of our story comes in: hybrid bonding. It's a revolutionary idea. Instead of using those little bumps as a go-between, this technique takes the copper surfaces on each chip, makes them perfectly flat, and fuses them directly together. There are no bumps, no gaps. And that means you can make the connections way, way denser, completely smashing through that old 10-micrometer wall.
And the jump in performance is it's staggering. By getting rid of the bumps and bonding the chips directly, you can increase the number of connections, the number of lanes on your data highway, by more than 1,000 times. 1,000. Let that sink in. This isn't just a small step up. It's a giant leap that unlocks the door to next-generation AI. We're talking about models so complex they can reason and create in ways we're only just beginning to dream about.
And that's exactly why companies you might have never even heard of are suddenly at the absolute center of this AI revolution. Hanmi Semiconductor. They dominate the market for a critical tool used in memory stacking today. And a company called Besi, they're a pioneer in the next-generation hybrid bonding machines. These are the companies that make the microscopic tools that build the silicon skyscrapers. They are the unsung heroes of this whole story.
Okay, so where is all this headed? Now that we know we can build up instead of out, just how high are we going to go? Well, let's take a look at the roadmap for what's called high bandwidth memory, or HBM. Just think of this as the super fast fuel tank that sits right next to the AI engine. Right now, with HBM 3 and 4, we're already stacking these memory chips so high that the old way of connecting them is really starting to struggle. But for the next generation, HBM 5 and 6, where we'll be stacking 12, maybe even 16 layers high, hybrid bonding isn't just a nice-to-have, it becomes absolutely essential. There's just no other way to do it. And looking out to 2029, even more advanced machines will come online, letting us build designs that are hard to even fathom right now.
And you can see how this one technology completely redraws the entire business map. Take a look at the customer base for an equipment maker like Hanmi Semiconductor. Back in 2024, their business mostly came from two big players. But as hybrid bonding becomes the industry standard, their reach is set to explode across the whole market, bringing in giants like Samsung. It just goes to show you, when you hold the key to the future, everybody comes knocking on your door.
So, when you boil it all down, it's pretty incredible. That crazy stock market frenzy, the whole AI supercycle. It isn't just about clever software. It's being built, quite literally, on top of these microscopic towers of silicon that are fused together with near-atomic precision. The real question now is, with this unbelievable new power in our hands,